Welcome back to Release Radar. I'm Chris Biscardi, and today we're finding out if Serverless Database means what you think it means. Heroku, Google's App Engine, and other products were early takes on abstracting your app from the servers it runs on. This wasn't a perfect separation. In Heroku, for example, users still had to provision things called dynos, while App Engine was closer in execution model with stateless apps and metered billing. Around 2015, AWS launched Lambda, the original functions as a service platform. That grew into functions as a service everywhere, or what is commonly known as serverless. These days, Azure, Google, AWS, and smaller companies like Netlify, Vercel, and Cloudflare all offer functions as a service with differentiated functionality from edge to classic. More recently, serverless has been adopted by database vendors to describe a version of their databases where they handle provisioning and scaling, freeing you up to focus on your application logic. Products under this banner include Amazon Aurora and Firebase. Today, we're talking about one more, PlanetScale. PlanetScale is built on top of Vitess, an open source project that the founders started. Vitess is all about scaling MySQL and originated inside of YouTube to manage YouTube's MySQL infrastructure. It was originally designed to run on Borg, which is Google's internal precursor to Kubernetes. So Vitess is some really cool technology, but unless you want to find out what VT gates and VT tablets are, PlanetScale is the way to go. PlanetScale is basically hosted Vitess with additional product on top. This product is enabled by abstracting the Vitess details so far away that you never really have to think about them, and currently focuses on enabling safe migrations through a Git branching model. PlanetScale's competitors in the branch model space seem, well, absent. AWS Aurora Serverless offers serverless MySQL, but all you get is a database and a connection string. You're not getting any additional product on top. When it comes to the Git branching functionality, you have development branches and you have production branches. Production branches can't be deleted. They're what are meant to be running your app in production, so deleting them would be, really bad. Development branches, on the other hand, are meant for individual developers to fork off, make changes, and then merge back into the production branches. Notably, data from the production database doesn't get cloned to the development branches when they're forked off. The CLI gives you access to list all branches, check diffs, and more, but there isn't suggested workflow for how to record those changes. It treats the MySQL compatible database as a blob of state that each chain forks and then gets merged back into, which to me accurately models the reality of most long-lived production databases, but also leaves some room for how teams communicate changes to the database amongst each other. PlanetScale does support comments on branches, but as far as I can tell, there's no integration with outside systems like GitHub Issues. PlanetScale also does some safety checks to make sure you're not pushing database-breaking changes over somebody else's changes. Production branches can only be modified by deploy requests, and those deploy requests are sequenced in a queue by default. There are additional settings to require manual human review before deploying, but those are not on by default. PlanetScale refers to their automated checks as non-blocking schema changes, which enables a level of safety I haven't seen in other RDBMS approaches. In PlanetScale, adding a column to a large table and other similar actions will not cause production downtime. It's not clear to me what automated checks are actually happening or how this works mechanically, so you might have to put some trust in the PlanetScale team's judgment here. Using these safety features also comes with a trade-off. Foreign keys are not supported. And to the PlanetScale team, this is a specific trade-off they chose to make, with a lengthy reasoning why. So what does serverless mean here? Can we access it from Lambda? The only way to access a PlanetScale database at the moment is through the CLI. This means running a MySQL shell or a proxy through the shell or connect functions in the CLI. Kind of interestingly, the pscale connect function in the CLI actually allows you to wrap the execution of your program in an environment that the CLI creates, which gives you the database URL that you would otherwise need to connect to the database. Unfortunately, this makes it unsuitable for Lambda functions at this time because there's nowhere to run a sidecar proxy, and we can't wrap our Lambda functions in the CLI to run it. And if I'm being honest, I'm not sure I would want to wrap my application in a third-party CLI. Although the underlying technology Vitess does bring down the cost of MySQL connections, so we could see Lambda support in the future. So lesson learned, a serverless database is still a database that needs to be checked for compatibility with serverless functions. The pricing is understandable, and there's a usable free tier. Compared to AWS's pricing, this is a breath of fresh air, which means that PlanetScale gets access to all the devs that are afraid of AWS's complexity, especially around billing. PlanetScale can be summed up as a serverless MySQL with branching-like features for schema evolution. It's an interesting offering, especially as a tool for future educational videos that teach or take advantage of SQL. But the lack of serverless function support means it doesn't fit into any of my projects at the moment. For that, I'll be sticking to DynamoDB. although I'll be watching PlanetScale and see if they release function support in the future.